Hi, everybody. So now it's time to talk about domain and range. All right. So let's go back once again and let's trace our parabola on the ridge. All right. So domain and range, right? So when you're talking about domain, right, we're talking about our X values, the possible input, right? Domain is our possible input. And we learn in unit 1 that it doesn't always have to be X coordinates, but in this case it is. It is the X coordinates. All right, so we want to know what is happening on the X axis. That's where we're going to look for our answer at, on the X axis. So let's look at the X axis. So this is the X axis, this is the Y axis, right? If we were to continue this graph on forever and ever and ever, right? This graph will get wider, wider, and wider. And are there any restrictions on a domain? Right? So first of all, let me talk to you about what restrictions on domain. So restrictions on domain would be if I'm dividing by 0 or if I'm taking the square root of a negative number. And so in the math of a parabola, I don't divide by 0 and I don't take the square root of a negative number. So is my domain restricted? No, it's not. So with that said, right? So when I look at this, I am clearly seeing that there is no restriction. It is going to get wider and wider and wider and wider until it goes off to negative infinity and positive infinity in both directions. So my domain for my is going to be for my parabola is always negative infinity to positive infinity. Another word for that is all real numbers. And another way to write that would be this fancy R. This fancy R is another way to write all real numbers. So, and that's just because there are no restrictions on the domain. There's no math that we're going to do that's going to allow us to be end up taking the square root of a negative number or be dividing by 0. Neither one of those cases are happening. Therefore, our domain is unrestricted. Now let's talk about range. Now with range, you want to look at what the x-intercept is again. Excuse me, not the x-intercept, the vertex is again. So remember we said our vertex was 4 and 2, right? So what is the y? So you look at the y coordinate, right? When you're looking at the range, you look at the y coordinate, right? So remember domain was your inputs, range is going to be your output. And so we're going to look on along the y-axis in this case. We're looking along the y-axis. All right, so I can see that the highest point on my y is 2. This is my max. Remember we talked about that before? This is my max. The y coordinates are not going to get higher than 2. But I can clearly see that the y coordinates are, the highest is at 2, and they're going down from there. So the way we write that is my range, again, the highest is 2. So let's get that. The highest is 2. And when you write an interval, so let me back up real quick and tell you how to write intervals. When you write an interval, you want to go low, high. You want to go low, high. So we're going to go low, high over here as well. Low, high. Okay? All right, so here we go. We see that the highest is 2. And that is going up to negative infinity because it's getting lower and lower and lower. So that's going to be negative infinity over here. Infinity always gets a soft bracket. So that's the reason why you saw me using a soft bracket here and here. Infinity always gets a soft bracket. And then we're going to put the hard bracket here, which means it's equal to, okay? Soft bracket means it's not equal to, and you can never be equal to infinity. And hard bracket means that it is equal to. So my range is from negative infinity to positive 2 because my highest value is 2, my lowest value is negative infinity. It is going off to negative infinity. And that is how you find the domain and the range. Thank you.